Hey guys, and welcome back to another video. And today we'll be preparing some phosphoric acid. Now this can simply be made from some sulfuric acid, which you can purchase as a drain cleaner from stores such as Rona or other hardware stores, and some calcium phosphate, which can be purchased from pottery supply stores as bone ash, which you can use in pottery and whatnot. Anyhow, the sulfuric acid could be distilled and purified, but for this reaction we should be able to use undistilled sulfuric acid and it should be sufficient. The drain opener I have here happens to be very clear, but even more brownish or greenish colored drain openers should be okay, and they're approximately around 93% sulfuric acid on average. So, for this reaction to begin, we're going to be needing to add 79.1 grams of calcium phosphate and 80.7 grams of drain cleaner. And we're going to be adding some water to this to help have everything dissolve a bit better. So, the calcium sulfate formed will be insoluble and should precipitate out, so we could filter that off, while the phosphoric acid produced should ideally stay in the water solution. So we'll probably also add an extra 5 grams of calcium phosphate, and this will just ensure that all the sulfuric acid reacts, so we only have phosphoric acid left in the solution. And because calcium phosphate is insoluble in water, any unreacted calcium phosphate can be filtered off, and then we should be left with a decently pure solution of phosphoric acid. So, as you can see by the addition of the sulfuric acid to the calcium phosphate, this reaction is very exothermic, as can be seen by the fumes. So we'll mix this thoroughly, add some extra water to dissolve the phosphoric acid, and then we'll go ahead and filter the calcium sulfate. Now, as can be seen here, I am using a vacuum filtration, as the solution is somewhat viscous. Even after adding that extra water, it is still relatively viscous, and a gravity filtration would take quite a while. So, after filtering, you can see that I have left it for about 8 hours to cool, and something else has precipitated, which is relatively odd. Perhaps it's calcium sulfate that was still in the solution, although it has very low solubility, and that seems very improbable, so I'm honestly quite confused and not exactly sure what this precipitate is. Anyhow, we'll go ahead and filter this again, because this is clearly not phosphoric acid. Phosphoric acid is very soluble in water and should not precipitate out at this current stage. So, I'll go ahead, filter it again, and then boil the solution. Now, I'm boiling the solution outside, as can clearly be seen in this Erlenmeyer flask here, and we're just going to continue to boil off the water and let it go off into the atmosphere until we see some white vapors. At the point of which we see white vapors, we're approaching the point of where all the water's gone, and we're starting to approach the point that phosphoric acid boils. That point, we'll install a simple distillation apparatus, which you can see just behind the hot plate here, and we'll distill off our phosphoric acid, which boils around 158 degrees Celsius. So the condenser water will have to be above 50 degrees Celsius so that the phosphoric acid will remain liquid in the condenser and doesn't solidify, as that would be negative on our condenser, as it would probably clog it, which is not a good thing to happen. So, once the temperature rises to 158, you can see we'll now begin collecting your phosphoric acid, and I'll just have it in the beaker. Something clearly has precipitated out in the Erlenmeyer flask where we're distilling from, but it mustn't be phosphoric acid because it's very soluble. So once again, I'm confused and unsure what is exactly precipitated out. But regardless, we'll just continue. So, now that we have collected this phosphoric acid in the beaker, you can see that we're just going to need to let it solidify. It is relatively liquid, but that's because the beaker is still very hot. Now we must cover this to prevent water absorption, or else the phosphoric acid will absorb water from the air and reliquefy itself. Okay, so I left the beaker overnight, which wasn't exactly the best, and I forgot to cover it, so it did absorb some water. That's not the end of the world, however, and you can see it's just a bit of a gummy paste, but we should still be able to get a decent idea of what our percent yield is and everything. So, here is our final phosphoric acid, and in a future video we will be using it, neutralizing it with sodium hydroxide through partial neutralization, eventually producing sodium hexametaphosphate, which we'll use to produce some white phosphorus. And I'll show that all in a future video and everything. Anyhow, this beaker here weighs 15 grams. However, due to water absorption, I'm more so thinking we have 11 or 12 grams of our phosphoric acid, which correlates to approximately a 24% yield. This isn't wonderful, but there was lots of losses. And you can see in this distilling flask beside, there's lots of phosphoric acid and impurities left over, which simply didn't distill over. And this flask should be easy enough to clean as it's all soluble in water, and water should simply rinse everything out. As a quick aside, if you wanted to, rather than going ahead and distilling to purify, you could just keep track of molar quantities on paper, and once you've filtered off the calcium sulfate from a couple steps back, then you'd have a solution of your phosphoric acid, and you should know the molar quantity based on the amount of chemicals you used at the start. If you know the molar quantity of the solution, you could then use that in future reactions, and it should just be you get a bit better of a yield, and it would be more easy to do. You would likely have more impurities, but depending on the reaction, that wouldn't necessarily affect anything. Anyhow, I hope you guys enjoyed this video, and I'll see you in a future video. Okay, bye.